Welcome to another video. Here I'll be solving the 1973 AP Calc BC multiple choice problems. Okay, I'll give my usual disclaimer that some of the content here might not be matching what's currently taught in AP Calc BC or whenever you're watching this video. I'm assuming you're a student of BC Calculus, so I'll leave it up to you to determine whether the problem is relevant or not. I believe most of them should be, but there for sure are like one or two at least in this multiple choice set that probably are not covered anymore in BC. But again, I'll leave it up to you. Okay, so I will probably solve around half the problems here, whatever I can fit in around half an hour, and I'll do the remainder in another part of the video. Okay, and one more thing. There's some problems that are the same as the AB exam given in 1973. I already posted the video for that, so I'll just refer to that video for the worked out solutions. I might give like a small hint here as to how to solve it, or not a hint, maybe like how to say this, recap of how to solve it is what, in my point of view, okay? So again, go to that video to see the full worked out solution. Okay, so let's begin. F of x is e to the 1 over x. F prime of x is equal to what? Here we just need the chain rule. So we first take derivative of e, which is e. So that's easy. And then we need to differentiate the inside, which is 1 over x. Okay, so it's e to the 1 over x times what's the derivative of 1 over x? Minus 1 over x squared. Okay, so that is A. Next, we have the integral from 0 to 3, x plus 1 to the half power dx, or the square root of x plus 1. Okay, how do we solve this? Well, we can do a little substitution. If you can do it in your head, that's great. This one, let me just do it. U is x plus 1. du would be dx. So our integral becomes, when x is 0, u is 0 plus 1, which is 1. When x is 3, u is 3 plus 1, which is 4. And it becomes what? U to the half du. So this is 2/3 u to the 3 halves. Evaluate from 1 to 4 by the power rule. Then we have 2/3 times 4 to the 3 halves power. What is that? That's square root of 4, which is 2. 2 cubed is 8. 8 minus 1, which is 2 times 7 over 3. 14 over 3. F of x is x plus 1 over x. Then the set of values for which f increases is... Okay, so did I work this out already on a separate sheet of paper? I should have. Can't seem to find it. Okay, that's okay. This talks about f when f is increasing or decreasing. That should signal derivative, first derivative test. Okay, so let me get a piece of scratch paper. Give me 1 second. It's not separating. There we go. Okay. So let's move this up. Okay, so we want to find f prime. That's just simple power rule again. It'll be 1 minus 1 over x squared. Okay? So we set it equal to 0. We find our critical points. We can change this to x squared over x squared minus 1 over x squared is equal to 0 because I want to combine fractions. This is equal to 1, right? So it's valid. Then x squared minus 1 over x squared is equal to 0. Okay? So then we can factor it as x plus 1, x minus 1, over x squared is equal to 0. So our critical points are x is -1, 0, and 1. Okay, we want to, the critical points are when this guy's equal to 0 or even when it's undefined. Okay, so let's do our first derivative test. We plug in a number, big negative number. The bottom is always positive, so we're okay there. Big negative number plus 1, that's negative. Big negative number minus 1, that's negative. 2 negatives make a positive. plug in like half, that's in between these two. This is positive, this is negative, so that becomes negative. Plug in like half, this is positive, this is negative. Okay, so this is negative. And we plug in a huge positive number, these two will be positive, so positive, okay? So it's increasing when x is less than -1 and when x is greater than 1. Okay, so that looks like choice A. Let me double check that's the answer, yes. Okay, for what non-negative value of b is the line given by y is -1/3 x plus b normal to the curve y is x cubed, okay? This I have worked out here. So here, the normal line is perpendicular to the tangent line. That's the key point. So the slope of this normal line is -1/3. So the slope of the tangent line is the negative reciprocal. So it's 3. Okay, slope of the tangent line, that's the derivative. So we want to differentiate y over here. Y is x cubed. So we differentiate y prime, it will be 3x squared. Okay, we set it equal to 3 because we want the slope of the tangent line to be 3. And derivative is slope of the tangent line. Okay, so we solve for x. X squared is 1, or x is plus or minus 1. Okay, so we have two possible points. And how I got the y coordinate, you just plug back into here. Okay, so let's test them one by one. We want to find b. Okay, and for b is non-negative. Okay, so we plug in 1, 1 into here. It'll be 1 is -1/3 times 1 plus b. We solve for b, we get 4/3. If we plug in the other point, we get -4/3. So b is positive, so it has to be 4/3. That's this guy. Okay, this one, integral from -1 to 2, absolute value x over x dx is, here you got to be careful because, first of all, this absolute value, you got to be careful if it changes sign, okay? And then also, I'm cautious also because is it improper integral? Because divide by 0 would give us problems, and 0 is within this interval. So you got to be careful about those two things. Okay, well, we realize that. Well, first of all, the absolute value x changes sign at x is 0. So when it's less than 0, so I broke it up, the integral up from -1 to 0, it'll be, when x is less than 0, it'll be on the negative x branch. Okay? When it's greater than 0, so from 0 to 2, so we're going up all the way up to the upper limit, it'll be positive x over x dx. Okay? So once again, absolute value changes sign at x is 0, so we got to split up our integral like this. Okay? From -1 to 0, 0 to 2. Okay, and then we can simplify. These would cancel, so we get negative integral -1 to 0 dx. These again would cancel, plus integral from 0 to 2 dx. So just do fundamentals linear calculus, that's -0 minus -1. Difference in the limits. Also difference in the limits here. We get -1 plus 2, which is equal to 1. Okay. This one I did in AB. Use the quotient rule. That's the key point. Okay, if y is ln of x squared plus y squared, value of dy dx at the point 1, 0 is what? Here we have to implicitly differentiate. So dy dx is equal to derivative of log, that's 1 over the argument, x squared plus y squared, and then times derivative of the inside, we need a chain rule. It'll be 2x for this one. This one is just 2y dy dx. Power rule, and implicitly differentiate, okay? Evaluate it at x is 1, y is 0. Okay, so we just plug in x as 1, y is 0. That's what I did over here. Then we simplify. This is 2, this is just 1. So 2 times 1 is 2. That's this guy. If y is sine x and y to the nth, the nth derivative, okay, with respect to x, this is what this is, excuse me, then the smallest positive integer n for which the nth derivative of y equals y is what? Well, here is just testing. We know that eventually the derivative of sine will go back. If you keep differentiating, it'll go back to being sine. So what is the smallest value of n. Okay, so we just start differentiating. Y is sine, then y prime is cosine, then y double prime, the second derivative. So the derivative of this is negative sine. The derivative of this is negative cosine. That's the third derivative. So we differentiate once more. The fourth derivative is sine. So when we're at the fourth derivative, we're back at sine. So 8 is A. 8 is B, sorry. I circled the right one, but said the wrong thing. Okay. Number 9. I did it on the AB exam. You just need to chain rule. Maybe this notation helps. Length of the curve. Y is ln of secant x from x is 0 to x is b, where b is between 0 and pi over 2, may be expressed by which of the following integrals. Okay, this is just using the arc length formula. Did I pre-work it out? Looks like I did not, so let me do it here. Okay, so arc length is integral from 0 to b, from the start point to the end point, square root of 1 plus dy dx squared under the square root dx, okay? So what's dy dx? That is just 1 over secant x times, we need to chain rule, times secant x tangent x. Okay? So 1 over the inside of the log times the root of the inside. So that's this, which is equal to tangent x. So 1 plus dy dx squared would be 1 plus tangent squared x. This is the same thing as secant squared x. This is literally one of the Pythagorean identities, okay? So it becomes integral from 0 to b, we square root of secant squared, which is just secant x dx. 10 looks like it's A. Very good. Okay, this is talking about differentials. It looks like let y be this guy when x is 0 and dx is 2. The value of dy is what? Okay, so when it's like linear approximation, differentials, usually it means tangent line. So let's find the equation of the tangent line at x is 0. Okay, so it looks like I did not do this beforehand either, so let me do it here. Okay, so y is equal to x square root 1 plus x squared. Okay, so y prime, we would need product, well, first d second plus second d first. First d second over 2 root that times 2x, okay, that should be good, plus second d first. So second d first derivative of x is just 1. Okay, this is the first derivative. Okay. Okay, this will give us the slope of the tangent line, but for differentials, it's even easier because this is a small change in y. Y prime is the change in y with respect to change in x. So we can say that dy is equal to y prime dx. Okay? So if you don't remember, differentials is talking about a small change in x. What's the small change in y? And we can use, since it's a small change, we can just use the slope of the tangent line to make an approximation. Okay. So let us just use this to plug in some stuff. So when x is 0, gx is 2. What's dy? Okay. So dy is equal to, let's plug in x is 0 to here. This would go away, right? Then we would have square root of 1 plus 0 squared, which is 0. Okay? And then we would have dx, which is 2. So is the answer 2? 11e, let me double check. Yes. Okay, as simple as that. If n is a known positive integer, for what value of k is integral from 1 to k, x to the n minus 1 dx is equal to 1 over n. Okay, so here, this is the integral. Okay, my intuition is let's just do the power rule over here, okay? So when we do the power, that will be x to the n minus 1 plus 1 over n minus 1 plus 1, which is x to the n divided by n. Okay? And we evaluate it from x is equal to 1 to x is equal to k. Okay? The right-hand side we kept the same. So the reason I wrote x is equal to 1, x is equal to k instead of from 1 to k is I'll get confused by all these variables. There's both x and n. I might plug into the wrong one, and actually did in my first attempt. So that's why I write it like this. I know to plug x as k and x as 1. Okay? So when we do that, the 1 over n, it doesn't depend on x, so I pull that out. We plug in x as k, so it's k to the n. Plug in x as 1, that's just 1 to n, which is just 1. Okay? That's equal to 1 over n, so the right-hand side, again, is the same. Okay, these can cancel out. So we have k to n minus 1 is equal to 1, or k to the n is equal to 2. Okay, and then we can just go like to the 1 over n power on both sides. So then k is equal to 2 to the 1 over n. That looks like D. Let me double check that's the answer. Should be, because I worked it out before. Yes. This one I've done in AB. We find the acceleration from this guy by integrating this guy. They give us the initial condition, so we can get a particular solution for v of t, and then s to 4 minus s to 2, we just do the definite integral from 2 to 4 of v of t. Okay? This one looks easy. If x is t squared minus 1, y is 2e to t, dy dx equal to what? Okay, so I'll just do it here. For parametric, it's easy to remember. It's dy by dt over dx by dt. Okay, so dy dx is equal to, what's dy dt? That's just 2e to t. The bottom dx dt is just 2t, which is e to t over t. This one I did in AB. This one's just simply setting up this integral. Okay, the upper curve is x minus e to x over 2. Lower curve is the x-axis, so we just integrate from 0 to 2 of the upper curve. Okay, series expansion of sine t over t is, this is very easy, because if you follow my recommendation, you should remember what the Taylor series for sine t is, or sine x. Okay, so I'll write it again here. Sine t is what? It'll be t minus t cubed over 3 factorial plus t to the 5th over 5 factorial minus t to the 7th over 7 factorial, so on and so forth. So you just divide everywhere by t. Sine t over t would be 1 minus t squared over 3 factorial plus t to the 4th over 5 factorial minus t to the 6th over 7 factorial, so on and so forth. Okay, so that looks like choice A. Okay. This one I did in AB. Basically, this is the rate of the growth of the bacteria, dB dt. We need to find b of t, and they give us an initial condition. Okay, and then after you find the particular solution of b of t, then you can find b of 5. Okay, let g be a continuous function on the closed interval 0 and 1. G of 0 is 1, g of 1 is 0, which the following is not necessarily true. Okay, so we can even just quickly sketch how this looks. G of 0 is 1, g of 1 is 0. So it'll look something, those 2 points will look something like that, okay? So let's go one by one. There exists a number h in the interval 0 to 1 such that g of h is greater than or equal to g of x for all x in 0 to 1. This is just the extreme value theorem, okay, since it's continuous everywhere. Okay, so it's going to have a value everywhere in between this point. There has to be some point where it's the absolute max. That's what this is saying. This is absolute max. This is true. Okay, so we eliminate that. For all a and b in the interval 0 to 1, if a is equal to b, then g of a is equal to g of b. Okay, this sounds true. And since g is continuous, then this should be true. Okay, so we eliminate that. There exists a number h in 0 and 1 in the interval 0 and 1 such that g of h is half. We can use the intermediate value theorem here. Remember what that says? Since we have some point g of 0 is 1 that is greater than half, g of 1 is 0 that is less than half, so half is somewhere here, right, in between. Since it's continuous, it has to cross the line y is half. It has to cross the value. It has to take on the value y is half sometime in order for it to go from here to here. It has to cross through half. So that's true. This one, g of h is 3 halves. We don't know. That's above this point, right? It'll be up here. We don't know if it will go up to there because it can just be a straight line down, okay, by IVT. So this is probably the answer, but let's look here. For all h in the open interval 0 and 1, limit as x goes to h, g of x is g of h. This is just definition of continuity. So when we know it's continuous. So the answer is D. Okay. Which of the following series converge? Okay. This is a convergent P series. This is with P is equal to 2. Okay, this is divergent. This is the harmonic series. Okay, so not that. This one, if we use the alternating series test, we can because 1 over square root n is decreasing, and then we take the limit as n goes to infinity, 1 over square root n. This is 0. So alternating series test says this converges. So 1 and 3. Okay. This one, we can do a substitution. You could probably also solve it with trig sub, but I see that we could just do it by substitution. So let me see where I wrote that answer. I think it's over here. Okay. So if we let u be inside the square root, 4 minus x squared, du is negative 2x dx. So this becomes square root u. We have x dx. That's du over negative 2. Oh, I forgot du. du over negative 2. Okay, so I pull the negative half out in front. Okay, so this, we just do power rule. So minus half, that's from here. 2/3 u to 3 halves plus c. And then we back substitute. This 2 and this 2 would cancel. So we have negative 1/3. And then we back substitute 4 minus x squared to 3 halves plus c. Okay, that is which one? Looks like it's E. Yes. Okay. This one I did in AB. This is another substitution. Okay. Excuse me. Particle moves on the curve. Y is ln x so that the x component has velocity x prime of t is t plus 1 for t greater than or equal to 0. At time t is 0, the particle is at the point 1, 0. At time t is 1, the particle is at point 1. Okay? So we have velocity of x. We can get the position of x by integrating. Okay? So x prime of t is t plus 1. That's what they give us. X of t, we do the power rule, half t squared plus t plus c. They give us that at t is 0, it's at point 1, 0. So x sub t or x sub t is 0, so x sub 0 would be 1. So x sub 0 is 1. So we plug in t as 0, 0, 0. So we're left with c. So c is equal to 1. So our particular solution for x is half t squared plus t plus 1. Okay? So now we're interested in the position at t is 1. So we can find the x-coordinate. That's just x of 1. That's half plus 1 plus 1, okay, which is 5 halves. Okay, so we found the x-coordinate, so we can eliminate actually all the choices, assuming we did it correctly. And we can confirm the y-coordinate because y is ln x, so y is ln of 5 halves. Okay, that's the answer. Okay, this one, I did it in the AB video. This is just f prime of 2, where f is ln x. Epsilon delta definition of the limit, I'm not going to go over that. This one, I did it in AB. You can change tangent squared to secant squared minus 1. Which of the following is true about the graph y is ln of x squared minus 1 in an interval -1 to 1. Okay? Talks about increasing, relative min, range, concave down, asymptote. Okay, so is this guy increasing? We have to find the derivative, y prime. In terms of relative min, let's probably find y prime for that also. Range of all real numbers. We know how the ln looks, okay? Ln does have range of all real numbers, so that should be true. But the thing is, over here, x squared minus 1, does that limit the domain such that the range isn't -infinity to infinity? So, x squared minus 1, so the minimum value would be when x is 0, because something squared is always positive, so when it's 0, ln of -1, or ln of absolute value of -1. So no, the range is actually from 0 to infinity. Sorry about that. So this is for sure not true, because the range is 0 to infinity. Okay? Concave down, we probably want to find a second derivative. Does this have an asymptote at x is equal to 0? No, because this is absolute valued, first of all. And then we just said that the smallest value that x can take is 0. Okay? So it stops at ln of absolute value -1 when x is 0. Okay? So this is, again, not true also. Okay? So let's find y prime and y double prime. Y prime is 1 over x squared minus 1 times the derivative inside, which is 2x, okay? Y double prime, we use the quotient rule, bottom d top, bottom times d top, what's d top? That's 2, derivative of the top, minus top, d bottom, derivative of this guy is 2x over bottom squared. We simplify, so I distribute this 2 to both those terms. This becomes 4x squared, so we get minus 2x squared minus 2 over x squared minus 1, x squared minus 1 quantity squared. So we can factor out a -2 on the top, then we get x squared plus 1 on the top, and then x minus 1 squared on the bottom, we left the same. So the critical point is only at x is -1 for the second derivative, okay? Let's look at the second derivative first, okay? So remember, we're only interested in interval -1 to 1. That's what the problem said. So what's the sign of the second derivative at in between this interval? So like we plug in x is 0. What happens here? This would be positive. This would be positive because something squared is always positive. But we have the -2, which is negative. So it becomes negative. So that we know that this is always concave down. Okay? So looks like it's D actually, but let's check for these two. Is it increasing, relative min? That's the first derivative test. Our critical points here are when x is 0, and then when it's undefined also, so that's -1 and 1. Okay, so we do the first derivative test, we plug in some number between -1 and 0, like half. This would be positive, this would be -half. So that's in here, this would be negative, this would be negative, two negatives make a positive. Okay, you plug in like positive half here, then this would be positive, this would be negative, then this would be negative. Okay, so it's increasing and then decreasing, so it's not always increasing. Okay, and relative min at 0, 0, no, it's actually a max, if anything. Okay, so those are not true, so we're left with D. Okay, and then I'll do one more problem in this video and call it parts, okay? F of x is 1/3 x cubed minus 4x squared plus 12x minus 5. Domain is a set of x, all x such that x is between 0 and 9. Then the absolute max occurs when x is what, okay? Here where did I do this? Okay, want to find the first derivative to find the relative max and min points, okay? So let's find f prime. You just do the power rule. F prime is x squared minus 8x plus 12. We set it equal to 0. We factor this guy to be x minus 6, x minus 2. Okay? So our critical points are 2 and 6. So we do the first derivative test. We're only interested in from 0 to 9. Okay? So that's why I wrote it like this. We plug in some point between 0 and 2, like 1. This is negative. When we plug in x as 1 here, this would be negative. This would be negative. 2 negatives make a positive. Plug in some number here in this interval, like 3, negative, positive, becomes negative. We plug in a number in this interval, like 7, positive, positive, becomes positive, okay? So we know that there's a relative max at x is 2. There's a relative min at x is 6. We don't care about the min because we're interested in the absolute max, okay? So we'll keep this point, but we have to also check the endpoints, okay? Because this is the absolute max. Okay, so we check f of 0, f of 2, and f of 9. Okay, f of 0, that's the endpoint. F of 2, that's the relative max. F of 9, that's the other endpoint. Okay, so f of 0, we just plug in 0 here. That's easy. That's negative 5. Plug in 2, x as 2. We get 8/3 minus 16 plus 24 minus 5. Okay, so we simplify that, becomes 8/3 minus 3. Now this point, it'll be f of 9. So there's math here, so it's complicated because 9 cubed is probably the hard part. But I just kept that as 81 times 9 over 3 minus 4 times 81 plus 12 times 9 minus 5, okay? These would cancel to a 3. This 9 and 3 would cancel to a 3, so 81 times 3, okay? And everything else I kept the same. This 3 times 81 minus 4 times 81, that's minus 81, okay? Negative 1 times 81, pretty much. 12 times 9, that's 108 minus 5, and then you can eventually solve to 22, okay? Which 22 is much bigger than 8/3 minus 3. Okay, what's this value? Well, if it's even 9/3 over 3, that's even bigger. That'll be 3 minus 3, which is 0. Okay, so it'll probably be like a little bit bigger than 0. This is obviously much bigger, so this is the absolute max. Okay, so that's the answer for that one. And I'll stop here for this part of the video, or this part of the exam, in this video, okay? So hopefully this is helpful. Please give this video a like if you did find it helpful, and please subscribe to look out for the second part.